Right. So before starting with the CEH part, let's just go with some basic fundamental for the cyber security part, right? So we will go with the cryptographic first, and then we go with the coming all the modules. So let's start with the CE. Let's start with simple cryptography first.
Okay.
So in cryptography, we will go through multiple things, and we will start with simple encoding. After encoding, we go with like simple encoding. After encoding, we go with encryption. What are the main encryptions we are using for the encryption part nowadays? After encryption, we will go with the hashing. Why we use hashing? What are the
Yes.
main part of hashing here? After
Mhm.
that, after hashing,
Mhm.
we have the one more thing to learn about simple digital certificates, right? So let's start with the
Okay.
encoding part. And for the
Okay.
encoding, we generally use like base 64 encoding technique. So I'll explain how to encode data into base 64 encoding technique. So for encoding, or you can say the main point for the encoding was like let's say we can read data which was written in form of like English alphabets. We can read the data which was written in Spanish, French, German, but only in human readable languages. If the system started showing the data in form of like binary values, right? I don't think we can read the binary values directly. So just to make the data compatible for both the user, for both machine and for the user as well, right? Because we can't analyze the data which was written in binary like this one. We can't just read this kind of data. We can only read the language we spoke generally, right? For that, machine convert that binary data into a human readable form. That conversion was the part of encoding. So you can say, like for simple English alphabets, my machine first convert that data according to ASCII characters encoding technique and then display it to me on the simple display screen here, right? That was the part of encode, just to make the data compatible. The encoding was just for the compatibility, right? So for encoding generally in the field of cybersecurity, just to make data compatible for all the machines, we generally use base 64 encoding techniques. So I'm starting with base 64, like how to encode base 64 and why we use
Mm.
base 64 out there. For base 64, you can use some multiple online platforms as well. Or if you want to encode the data manually, you can encode that as well. So for encoding into base 64, let me just code a message. Or before that encoding part, let me just explain few terms here. So few terms was, let's say that you can say start with simple plain text, like all the input, all the text, all the data, all the messages you can say which you want to encode are the part of plain text, the actual content, right, which have to be encrypted, which have to be encoded, is known as the plain text. The initial data, right, is the part of plain text. Then after
Good,
that,
good
the
evening.
algorithm. Sorry, hello.
Good evening, sir. This is Rajai with you.
Yeah, hello Rajiv, how are you?
Doing well, thank you. I'm sorry for the late because I was in the highway between two cities, so now I reach the other city.
Not a
Uh,
problem. We have just started with the part of cryptography. I'm just explaining few basic things. So don't
Oh,
worry, you haven't missed anything.
thank you, sir.
We just started this. Yes.
Take care, sir. So,
Okay. So after plain text, we have the second term, we generally call it cipher. Again, cipher is just the algorithm which was used to perform that kind of encoding, perform that kind of encryption or hashing. But the mathematical algorithm is known as the cipher. And the outcome of that cipher is generally known as ciphertext, right? The outcome is known as the ciphertext. So for encoding, let me just go with simple example here. So let me say I have a simple plain text as a simple message HEY. I'm using capital H, small e, and small y just to encode the data into base 64. All I have to do is first calculate the binary values for all these characters HEY according to ASCII character set, or you can say ASCII table, right? So for conversion of this message HEY into binary, you can use some tables or you can just use some online platforms as well. If you want, you can just remember this table. Let's go with like ASCII values in binary because we have to convert the characters into binary, right? So you can see for the character H, if we just came here, for the character H, The binary value was, or you can see the decimal value was 0.72, and the binary value for 0.72 was here, this one. So what I can do, I can just copy this value and paste it here. This is the binary value for the character H. So I'm just writing character H here, and just paste the value here. This is the value for character H. After H, what we have is small e. We just enter the character here, and let's just copy the character E value. So character E has a value in decimal in ASCII table was 101, right? If you just go with the ASCII table and identify the decimal value for character E, small character E, we got the value 101. And if you just convert the decimal value into binary, you got these values 011 00 101. Again, just copy the decimal value, copy the binary values here, and again paste them here. Just give it a space and paste the binary value for character E. After E, what we have is the character Y. Just follow the same steps for the character Y, and for the small y, the value was 121, and the binary value for 121 was here 011 11 001. Right, so just paste the value here. Right, so we got the binary values for the capital H, for small e, and small y. After that, all you have to do is just create a pair of 6 binary values. Create the pairs of 6 binary values. Let's just pair them. The first pair would be like these binary values. Just copy them, and let's just paste them here. After that, again create a pair of 6 binary values. You just copy 6 binary values and paste them here. Just erase that space from here. After that, let's go with one more pair. Again paste it here. We may remove the space, and the last pair of 6 binary values, and just paste it here. Right. So after pairing them for the group of 6, all you have to do is compare this binary value. Right, or what you can do, just convert this binary value into decimal, and then you can go with the base 64, or you can directly compare the binary value with base 64 table. If I just search here for base 64 table, we got some output. Let's go with Wikipedia. And just wait for a second. So here we got the values. If you scroll down, you can see we have the decimal values for all these base 64 table, and we have the binary values with the characters. Right. So all you have to do is just compare the binary values. If I just move it aside and keep my paint on the other side, so I can just compare the values in a better way. Just copy the first pair, just select this first 6 binary values and search here for the exact match. Right, for this one, for this exact match, we got the character S on the place. Right, the first binary match was like 010010, and for this binary value we have the character S here. So we just simply place the character S here, and after that, let's go with the second pair and follow the same steps. Just copy the binary values and search here for the match. We got the character G here. Okay, let's go with character G here. After G, the third pair, and for the third pair, follow the same steps. Copy them and search here for the match. We got the character V. All right, just write the character V here. After that, again, follow the same steps. Copy the binary values, and you can just search them here. We got the character 5. Okay.
V.
Right.
No,
Again, the steps were same here. Again, the steps were very simple. All you have to do is just write your message, convert them into binaries. After converting your message into binary, just create a pair. Just create pairs of 6 binary values and compare these 6 binary values for the pair of binary values with the base 64 table, and just write the corresponding letter here. These are the simple basic steps for base 64 encoding. If you just use some kind of online encoder for base64, you can use just search here for base64 encoding. And you can write your letter, you can write your message. Let's go with the same one, HEY. We just go with encode, and we got the same base64 encoded text, SGV and 5.
You
This
are
was
right.
our output. Yeah.
You are right.
So other than this simple base64 encoding, let's just get back to the next topic. We have the encryption part, right? So for encryption, you can use multiple algorithms, and you can say encryption was mainly used to maintain the confidentiality. If you remember the last section for the confidentiality, integrity, and availability for the CIA triad, right? Out of them, we use just to maintain the confidentiality. We generally use encryption just to convert the data in such a form that can only be read, this can only be analyzed, right? Or that can only be understood by some specific or specified persons, right? Just to convert the data in such a form which can only be understood by some authorized persons only, right? So encryption was generally used for the confidentiality, right? And to convert that data into into some unique form, right? We generally use some string values, and we call it the key. To convert the simple plain text with the help of ciphers, we generally use some string values, and we generally call them keys. Again, keys were nothing special here. Keys were just simple alphanumeric string values which were used to convert the data in such a form which is not understood by all the employees, all the, you can say, all the people. Right? They can only be understood by some authorized person only, and they can only read the data when they have the exact same key, right? Or you can say when they have the corresponding similar key. Only then they can read the data. Otherwise, they cannot. There is no such way to crack this kind of encryption. There is no such way, right? So for the encryption, we just convert the data, and for that, we have different ciphers. We have different algorithms, which you can say, like the one which was generally used, which was the DES, or you can also use the AES. Again, just to standardize, just for all these kind of standards, organization was there which was used. NIST was the organization which generally standardize all this kind of encryption and all this kind of hashing algorithms, right? So all this like AES and DES was standardized by the NIST again. So if you just go with simple DES first, the important factor about any kind of encryption algorithm, like if I just write down these the important factors about any encryption algorithm, what the block size, like if it was a simple block cipher or stream cipher, I'll come back to that part. Like we have two types of cipher. We have two types of cipher. The first one is block cipher. Second one was stream cipher. If you just go with a block cipher, they can process a fixed amount of data at a time. Let's say, like they can encode or they can encrypt a fixed amount of data. Like say, I can only encrypt like 128 bit of data at a time, right? You have to provide me 128 bit. It can't be 127. It can't be 129. It should be 128 bits only, right? When we have this kind of situation, when you have this kind of condition for encryption, for encoding, decoding, whatever it was, at that time we generally call it block cipher, the algorithm which work for a fixed amount of data, right? We call them block ciphers. But on the other hand, if I talk about stream ciphers, these mathematical algorithms can work with variable amount of data. Let's say, like I have a range, like I can encrypt, I can encode minimum length of 8-bit data, and I can encrypt up to, let's say, like 128 bit of data. Right? But I can go with the range. I can encrypt 16-bit as well. I can encrypt 20 bits as well. I can encrypt 21, 22. I can encrypt these. I can encrypt any length of data, but only between this specific range. Right? But you can encrypt variable length at that time. Let's say you have a message, HEY, HEY, right? If you want to encrypt this message with the stream cipher, you can do it easily. You don't have to go with some kind of padding or some kind of null bytes, right? But if I want to encrypt the same message, HEY, right? So all I have to do is if I just count the binary values, count the length of this message HEY, it would be like 8 3 24 bits here, right? This message length was 24 bits. So I have to complete like 128-bit block size, and we only have 24 bits here. What my system will do? My system will add 104 null bits, you can say, just to complete that block. Just to complete that block, my system will add some null bytes, right? So that our encryption, our cipher can perform the encryption, can perform the encoding. That was the part of block ciphers. Other than this, we have two kind of encryptions as well. This was the ciphers, type of ciphers. The second thing we have is type of encryption. We just talk about type of encryption. The first type was simple symmetric encryption.
Symmetric and asymmetric.
Yes, symmetric and asymmetric.
You know, Siddhar, I read about this one in the ITIL. I take it in the CCSB. I take it. But still, I'm not. I don't know how we can use it as a practical. This one, just we are take it in the just reading. That's all.
So if you want, you can just write some code for the practical part, or you can use some website platforms as well. You can use some web portal for the encryption and decryption part, or you can just write your own code.
Excellent.
Again, it's your choice how you want to perform that encryption.
Nice.
Yeah. So for the symmetric encryption, so let's say I can encrypt. I can just convert the data in a unreadable form, right, with the help of some unique key. And just to get data back from that unreadable form, I have to use the same key. Let me just show you the example on the right hand side on the Firefox here. Let's go with like online. Okay, yes. Yeah, here we can go with. Let me just write a message like, hey buddy, how are you? Let's say I'm writing a message to my friend, right? This was a message, hey buddy, how are you? So just for the encryption, I have to go with 128-bit key. With AES, we have multiple variable key length. I'll come back to that part later. But again, here we have to specify 128-bit key, right? So let's go with 128-bit, or you have to enter 16 characters, right? Just go with 16 characters like 1, 2, 3, 4, 5, 6, 7, 8. Again, 8, 7, 6, 5, 4, 3, 2, and 1. Right? We go to 16 characters. My output will be encoded into base 64. So if you want, you can just decode it. Otherwise, you don't have to decode it, right? So I have my plain text, I have my actual message, and I want to convert it into an unreadable form, right? So just go with the encrypt part, and we got our unreadable form data. The output was known as the cipher text. The encryption algorithm I'm using here is the AES. That algorithm is known as the cipher, right? So if my victim, or we can let's say, if my friend wants to get the message back, right? While transmission, I'll send that I'll send that message, this one. The output I'll send to my friend, right? And after receiving this message, this output, what my friend will do? My friend will just decode. My friend will just decrypt that data into actual message, right? For that, he have to use the actual key I have used there. He have to use the same key. Only then he can decrypt the data. So again, that message was received by my friend. If he have the same key like this one, only then he can decrypt the data. If I'm using the same key, I can just decrypt. Again, it's basically for encoded, so I have to go with like decode to plain text. So just, yeah, now it's visible to you. So I have to go with the same key. Only then I can just decrypt my message, right? If I use the different key, like if I use 0 and try to decrypt it will give me an error, or I cannot decode into plain text. Suppose we have some decryption errors here, right? So the point is, all you can do just to crack this kind of encryption, what you can do, you can just go with a brute force, right? So if I just go with simple brute force, if I show you a picture like brute force speed, let's go with images here, and let's go with this one. So we have some metrics here. You can just see here. If I'm using, I was using 16 characters, so we have the 16 number here. Like if I'm using numbers in my key, right? And for the 16 characters length, it will take around 4 hours to crack the secret, to crack that key, if I have used numerics only, right? But if I have used lowercase letters only, without any number, without any uppercase, without any special characters, right? I have only used lowercase letters in my key, in my 16 character key, right? Then it will take around like 143 million years to crack that key. And I don't have that much time, right? So all you can do is nothing. You can't do anything for this kind of encryption if you don't have the key. But the point is, you have to use the same key if you want to decrypt it. Only then you can just decrypt that data. If you have the exact same key, right? And this kind of encryption, where you have to use the same key for encryption and same key for decryption, that kind of encryption was known as symmetric key, in which we use the same use
Yes. Same
same key for
secret
both.
key. Yeah.
Yeah, for encryption and decryption, right? But
Sir, I have a small
yeah,
question here.
yeah, sure.
If you don't mind. Here, there's something I think called public key and private key. Isn't this one the same what we are talking here, or something different else? Private key
I'm,
and public key.
I'm coming to that point. I'm coming to that point.
Okay, sir.
Yeah. So the public key and the private key was the part of asymmetric key encryption. In the asymmetric key, you can't specify the secret key by yourself, because for the asymmetric key encryptions, the key length was large. Like it could start from like 515 bits, right? And it could goes up to like 4096 bits. Because of that key length was large, and you have to go with like two different keys. So your system will automatically generate two different unique alphanumeric string values. Your system will itself generate two alphanumeric string values, right? One was known as private key, through which you perform the encryption. Second one was known as the public key, through which we perform the decryption. But sometimes, or you can say like 80% of the times, we perform the encryption with the public key, and we perform the decryption with the private key, because the public key was shared among multiple users. Let's say you create a public key and private key, right? You keep one of them to yourself, and you share the other one to all the colleagues, right? And if your colleagues want to write a message to you, they will use that public key to encrypt that message, so that only you can decrypt that message, right? Because the other pair, because only that other pair could be used to decrypt that data. If I just show you the example for that, let's go with like online RSA. Again, go with the same thing. Again, you can go with multiple key lengths here. I'm just going with by default 1024 bit. My system will automatically generate the keys here. Again, there were alphanumeric string values in which we have some uppercase, lowercase, and special characters as well, right? And if I just go with the brute force to crack that alphanumeric string value, if the key length was 10 characters, even then it will take around like 330 years to crack that key, to try all the possible combination for those alphanumeric values. It will take around like 330 years, and I am not sure I will living for 330 years or not, right? So I have created a key for 1024 bit. We got one key, and it was known as public key, and the other one was known as the private key. Again, you can perform encryption with any one of them. So I'm just using this private key for the encryption here. So just copy this private key, and place it here. I have secured the private key. Just select the private and paste your key here, right? After that key part, after that key, you have to specify some message. Again, write your message to your friend like, "Hey buddy, how are you?" Right? This was my message to my friend. So if I just perform simple encryption, again the output was best encoded. It doesn't matter for me right now. But again, we got our encryption, we got our ciphertext here, we got our output here. If my friends, if my friend want to decrypt that data, right? If we have the second pair, if we have that key pair for the public key, only then he can decrypt the data. Only then he can decrypt the data if we have the key pair. If we don't have the key pair, or let's say if I just uh, change this, or let's say if I'm using the same key for the decryption, I'm just copying this key here, copy it, and just paste it here, right? And if I after that, if I just try to decrypt that data, this will give me an error because I can only use that key for encryption or decryption, one of them. But I can't perform both the steps for encryption and decryption with the same key. Right? I have to use the other key pair for the decryption part. So if you have the same key, only if you have the other key pair, only then you can just decrypt the data. Otherwise, there is no such option to crack that encryption, right? So RSA was the part of asymmetric encryption in which we use different key for encryption and decryption. Right? Our system will automatically generate two key pairs, one for encryption and other for decryption only.
So
Right?
we'll use the public key for example, if you are take example for the sender or receiver for email, for example. Let me
Okay.
okay. Give me example for this one. For example, I am sender and you are receiving the email. I will send you encrypted message. I will use your private key or your public key to send the message or what?
You don't have my private key. I'm the only one. You can say, let's say, like when you generate the key pairs, right? You keep one of them to yourself and you just share the other one to others. That was a simple basic situation. The
Yes.
shared key was known as the public key, which was used
Okay.
for the encryption most of the time,
Yes.
right? So you encrypt that email with the public key, and I will decrypt that email with the private key. But when you are
Okay.
signing, let's say when you go with the simple digital signature part, right? In case of digital signature, we just encrypt that data with the private key, and just to verify that signature, we use the public key. Again, it depends on the situation. Again, it
Yes.
depends on the scenario, right? Who was decrypting the data? It depends. But again, the other key pair, the only key pair could be used for decryption. You don't
Okay.
have any other option. Like as I shown you in the simple brute force speed, you can say. Again, this speed was for the fast computers, not for simple normal computers like us. And if you have a 10 characters or you can say 9 character long alphanumeric keys, for 9 character long key, it will take around 2 years to crack or to try all the possible combinations, right? But if you have like
Okay.
20 or other, I can't even read that line. I can't even read that period. Like 2 SPT and ES. I don't know how long this is. But again, I don't want to go with this part.
Yeah.
Yeah. So other than this simple type of encryption like asymmetric or symmetric, let's just get back to the DES. The important factor about any kind of encryption was the block size. It was simple a block cipher or a stream cipher. That was the part. So for the block size, for the block ciphers, we have the block size, or for the stream cipher again, we have the block range, right? But again, we have the blocks out there. So first thing was block size. Second thing was your key size. How long key you are using. Like for the 16 characters, 10 characters, 8 characters, or 20 or 50, or how long key you are using. Again, it depends. If you are using a long key, it makes that data more confidential, right? encryption was more stronger if you are using the longer key. But again, for long keys, encryption was generally slower. That's why all the time, in the case not all the time, 90% of the times, your data was encrypted with the symmetric key. But for the symmetric key, both the users should have the same key pair, right? Should have the same key for decryption and for the encryption. And just to share that symmetric key, we use asymmetric key encryption. Just to share that symmetric key, we use asymmetric key encryption, right? So, other than this simple block size and key size, we have the third thing that was known as simple number of rounds. Because in most of the encryption algorithm, right, you perform multiple rounds for the same function. Let's say I perform a function for the encryption like 10 times or 15 times, right? I'm encrypting the data 10 times or 15 times. There was the number of rounds here. How many times you're encrypting or you are performing the encryption function over that block? That was the part here. Number of rounds we generally call them. So if I talk about, let me just give it a tab. You can write the encryption algorithm name here. Yeah. So if I just go about DES, in case of DES, the block size was like 64 bit. Right? You can only encrypt 64-bit data at a time, or you can say you can only encrypt 8 characters at a time. Other than this simple block cipher, the key size for the DES was again same 64-bit. You can say the key length was 8 characters, right? Which can easily be cracked here. Other than this simple key size, we have the number of rounds, and for the DES, the number of rounds were like 16. You perform the same encryption function 16 times over that specific block of data, right? We have 16 number of rounds here for the DES. But if I talk about AES, for the AES, we have different key sizes. But again, the block size was fixed 128-bit. You can only encrypt 128-bit of data in the DES at a time. Again, we have multiple key sizes for the AES, like you can go with 128-bit of key size. And for the 128-bit key size, we have 10, we have to perform the same encryption function 10 times here, or you can also call them 10 rounds, right? Other than this simple 10 rounds part, we have the second one, in which again the block size was 128-bit, but again the key size was different here. But this time the key length was 192-bit. So you can say 24 characters, right? Which is again a more lengthy key, means more stronger encryption. And for the 192-bit key, you have to perform 12 number of rounds for the data, to perform the proper encryption. After that, we have one more key length which was available for the AES. Again, the block size was 128-bit, but the key size was 256-bit. It means 32 characters, right? You can start from 16 characters and you can take it up to 32 characters for the key size. And for the number of rounds, for 256-bit key, it was 14 rounds, right? So this was the important factor which you should know about any kind of encryption algorithm.
Hmm.
The most important was the key size, right?
Yes.
Larger the key, stronger the encryption, you can say. Or you can say more combinations were there for the key. Just to crack the key, you have to try more combinations if you want to crack that key.
Yeah.
Other than other than this simple encryption part, then we have the hashing algorithms. If you remember the last session again, like I have told you about integrity part, like how you check for the integrity. That the letter which was written by the Raje to the Surya, how Surya will ensure that the letter was actually written by the Raje or not, right? Or the data which was in that letter was modified or not while transmission. And
Yes.
for this to ensure this kind of modification, to verify this kind of modification, we generally use hashing. So hashing was generally used to identify the integrity. right?
Okay. Yeah.
So let me just give you a better example for that part, so you can better relate these things. So just go with online. Again, I'm going with online hashing. Just go with any link here. So I'm using a simple hashing algorithm, SHA, that stands for secure hashing algorithm. Not simple hashing algorithm, secure hashing algorithm, SHA-256, right? So let's go with a simple message. You just get here and let's go with simple message like HEY. I have to write the message here, HEY. Again, H was capital, E and small y. And let's go with the exclamation as well, right? Let's say Rajal wrote a message on WhatsApp or email as well to Surya, right? With that message, what Raja will do, Raja will bind that hash value. Raja will calculate the hash value according to this algorithm, SHA-256, and bind it with the message,
Yeah.
right? So let's say for this message, HEY, this was my hash value, right? And let's say while transmission, I'm the malicious person. If I just remove this simple exclamation here, the hash value will be completely changed. And let's say this was my second hash value for the message HEY only. We don't have any exclamation symbol here. And for this message, we got this hash value, right? So after receiving that message, what Surya will do, Surya will again calculate the hash value for the message received by him, right? Calculate the hash value and compare it with the hash value received with that message. If these two hash value are exactly same, only then Surya can trust that this message was written by Rajan, right? And all the hashing algorithms, so which were generally standardized by any organization, not only by the NIST, all the hashing algorithms have some functionalities. Like the first one was the avalanche effect. Avalanche effect means if there was a change of single bit in the input, if we change a single bit in the input, the hash value will be completely changed, right? That was, we call it avalanche effect. If you change a single bit, the output will be completely changed, right? That was the avalanche effect. And all the hashing algorithm should reflect this avalanche effect, should show this avalanche effect. Then the second one was, we generally call it collision. So collision means, let's say, if anyone was able to generate two hash values, right? If anyone was able to generate the same, don't go with two hash values. If anyone was able to generate the same hash value for two different input, like same hash output for two different inputs, it doesn't matter like what input you are using, what length you are using for the input. But again, if you can generate the same hash value for two
Mm.
different inputs, at that time we call it the hash collision, right? And all the hashing algorithms which we generally use should resist this kind of collision. They have to resist this kind of collision, right? Just to be standardized, they should resist the hash collision and they should show the avalanche effect. Only then they will be standardized. Other than this, if you remember, if you have learned a little bit about the networking part, we have a thing we generally call it TCP three-way handshake, right?
Yeah, I know this.
Yeah. So after TCP three-way handshake, what our
Knowledge.
machines will do, our machines before sharing data between the receiver, before sending data to the receiver, before sending data to our receiver, first my machine will confirm like which encryption algorithm I have to use for the encryption, which algorithm I have to use for the hashing, right? And the negotiation for this hashing algorithm, for this encryption algorithm, was known as generally SSL handshake, in which two machines will negotiate about this encryption and hashing algorithm. And the combination of hashing and encryption algorithm was generally known as cipher suit, right? If I show you in the browsers, you can just go with any website, just go with this lock here, go with more information out there, and you can see for all the websites, just get back to the technical details here. Connection encrypted, we are using TLS. Encryption algorithm was 1 to AES, the Advanced Encryption Standard. Again, AES stands for Advanced Encryption Standard, and your DES stands for Data Encryption Standard. And nowadays, like most of the time, you will encounter the AES instead of DES. DES was not used anywhere nowadays, but AES was used almost everywhere, right? So we were using AES 128 bit here. Then we have the GCM. I'll came back to the GCM part just after that simple cipher suit. Then we have GCM. I'll come back here. Then after GCM, we have the SHA-256, the hashing algorithm I was using, right? So the combination of encryption algorithm and the hashing algorithm was generally known as the cipher suit, right? Then after that, what is this GCM? GCM was just the mode of operation. GCM was just the mode of operation. Like if you want to increase the efficiency, if you want to make that output, if you want to encrypt the data more strongly, at that time you use different modes of operation. If I just go through that part, let's go with like different modes of encryption. Just go with Wikipedia. So for the picture part, I'm going with Wikipedia here. Just zoom in. You can see like it start with simple ECB. Or this one, yeah. So it starts with simple ECB, that stands for electronic code book, in which you just provide the input, provide your plain text, you provide the key, and the encryption will be followed on the data, and you get the output, you get the cipher. This one is simple encryption. We call it ECB, electronic code book, right? Then after ECB, we have one more, which is generally called as CBC. CBC was there. You have to provide the plain text. You have to provide the IV, which is generally called initialization vector, or you can also call it IV as well. This symbol, the plus inside that circle, was generally used for the XOR operation.
Okay.
It means first your plain text will be XORed with your IV, then the encryption will be followed over the data, right? The outcome will be the IV for your next block. The outcome will be the IV for your next block, right? And you got your ciphertext there. Other than this simple CBC, we have one more. We call it PCBC, like propagation cipher block chaining. Again, the steps were same. You have to XOR, like just to create the IV for the next block. You were just XORing the plain text with the ciphertext, and then you got the IV for the next block. The only difference is, right? If you just after that part, we have the CFB. We generally call it cipher feedback, right? So for the cipher feedback, you have to provide the IV. Now here for the CFB, you are encrypting IV. You are not encrypting your plain text here. You are just performing encryption over the initialization vector or the IV, right? You provide the IV, you provide the key here, and the encryption will be followed on the IV. You got the output. That output for the IV encryption will be XORed with your plain text. And after XOR, you got your result as your ciphertext, right? And that output after XOR will be used as the IV for the next block, right? And this steps goes on. After a simple CFB, we have one more, I think. Yeah, we generally call it OFB, outer feedback. Again, outer feedback was simpler. Outer feedback was simple here. But the only difference is, if you remember the CFB, we were just first XOR the plain text and then we got the value for the next block. Then we got the IV for the next block, right? But before sending value for the next block, first we XOR the output with the plain text and then we send the data for the next block IV. But on the outer feedback block, we were just using the previous value. We just encrypt the IV with the key, we got the result, and that result will be used for the next block's IV, right? So you can process this layer. Like you can just use the IV, you can just use the key, you can just give the plain text whenever you want. You can just perform this kind of encryption more faster, right? So you can just ensure the data and you got your output. Simple thing. Now after this OFB, we have the CTR in which you use like a nonce value and a simple key with that part. So for the key, you have to like in the older in all these kind of modes of operation, we generally provide IV, right? So but in the CTR, instead of IV, we were using a random nonce value here, and with that nonce value, we were using a counter that starts from zero. Like when you are encrypting the first block, the counter will start from zero. When you encrypt the second block, the counter will be increased by one. And when we're encrypting the third block, the counter value will be two, right? So your counter will be increased by one all the times when you perform encryption on next block. The point is, so again, the steps were same. You use the nonce value, you use a counter, you provide it as an input for the encryption, you give it the key, encryption will be followed, and that output will be XORed with the plain text, and you will get your cipher text, right? So this is simple CTR. We have multiple other modes of operation, but again, the point is how your data will be encrypted. Okay, there is nothing different than this, the basic encryption part. There were just different kinds of encryption. There were just different modes of operation. How to provide that input and how to process that encryption part. That's the only thing, right? So a combination of this encryption algorithm and hashing algorithm is known as the cipher. Is known as cipher suit, you can say. One more thing about all these websites, if we just get back out there, if I go with more information, like we can see a certificate was there, right? All our systems, all our browsers verify the software, verify the website with this certificate. Like let's take a simple example. How my browser will verify that the website I am visiting is the actual wikipedia.org or not, is a trusted website or not, right? This trust, you can say this trust was verified with this kind of certificates, right? Just because, let me just give it a draw. So I'm going with a more paint window. Okay, let's say you have some money and you want to deposit in a bank, right? So you don't know which bank was trusty, which bank was trustworthy. You don't have any idea. At that time, what you will do? You only trust on government. Let's say like government was a trusted authority. They will not do anything wrong with my money. The only point is, let's say this is your user here at the bottom, and let's just name it them here. So this is my government, right? This was my, let's say, a governing authority by the government itself. We call it RBI, the Reserve Bank of India. Right? We call it RBI. So under RBI, we have one more bank. Let's go with SBI, the State Bank of India, we call it. Let's say your user trust on government, that is the government is a trusted party, right? Let's say, and your government trust on one more authority, you can say your government has a legal authority, trust on the RBI, right? Your user trust on government and your government trust on RBI and your RBI trusts on SBI, right? With this simple trust value, with this simple trust chain, your user can also trust on SBI that this SBI bank will will take care of my money, right? So this is just a simple trust chain. The same trust chain was followed by your browsers, right? All your browsers have the public key for the government level signing authorities. Like whenever you create a product, whenever you develop a software and kind of application, kind of website, right? You need to sign it with your key. You need to sign it with your private key. That was a part of simple digital signatures. You need to sign your product with your simple private key. But the point is, who give you the authority to sign your product? Let's say SBI can sign their product. SBI can sign their product. Being a developer, let's say SBI have some developer, they develop an application for the mobile, right? And they just sign that application with their own private key. But they were authorized by the RBI, and RBI was authorized by the government here, right? Same trust chain, same authority chain was followed by your browsers out there. If you just go with view certificate here, you can see Wikipedia was the actual organization, was the actual website, right? This Wikipedia created a website and signed it with his private key because Wikipedia.org was authorized to sign his products by DigiCert, right? And that DigiCert was signed by one more government level authority. We call it DigiCert High Assurance EV Root CA, right? So this one is just the root level CA, we call them, who actually authorize others so they can sign their product, right? So and we generally call them root level CA. CA was just for the short term for signing authority here, certification authority, signing authority, whatever you call it. Then the RBI, or you can say the intermediate CA, we generally call them intermediate level CA, right? And this was the actual signing authority or the actual CA, you can say,
Yes.
who was signing their own products, right? So same trust chain, same authority, same permission chain was used to verify the websites you are visiting. With this simple trust chain, your browsers ensure that the website you are visiting with on the name of on behalf of Google is actual Google or not, right?